Welcome to EMERTXE IoT-based home automation internship. My name is PAVAN V. I am from 4th year mechanical engineering of Sri Venkateshwara College of Engineering and Technology, Andhra Pradesh. The content includes C programming, C++, IoT, embedded systems, home automation project. C programming. C is a general purpose programming language. C programming is considered a middle level language because it combines features of both low level and high level programming languages. C is machine independent and structured and can be used for both system and application programming. For example, C can be used to write operating systems or generate customer building systems. Topics learned in C: data types, modifier and quantifier, conditionals and loops, operators, array and pointers, strings, function, storage classes, preprocessor. C++. C++ is a general purpose programming language, GPL, used to build software. It's an object oriented language, which means it focuses on objects or data fields with unique attributes rather than logic or function. For example, I a user account on a website is an object that can be replicated when a new account is created. Internet of Things. Internet of Things is a network of physical objects or things that have sensors, software, and other technologies embedded in them. These devices can connect and exchange data with other devices and systems over the internet or other communication networks. IoT devices can range from everyday household items to complex industrial tools. Embedded systems. An embedded system is a combination of computer hardware and software designed for a specific function. Embedded systems might also function within a larger system. These systems can be programmable or have a fixed functionality. Embedded systems are used today to control numerous devices. For example, they are used in industrial applications, consumer electronics, agriculture and processing, industry devices, automobiles, medical devices, cameras, digital watches, household appliances, aeroplanes, vending machines, toys and mobile devices. Home automation system. This project combines sensor-based automation with remote control capabilities, enhancing convenience and energy efficiency in managing your home gardening, light, climate control and water supply. Garden light automation utilizes an LDR, light dependent resistor, to control the garden lights automatically. The garden lights turn on at dusk low light conditions and turn off at dawn high light conditions. Second one, heater and cooler control. The heater and cooler are controlled using Blink app, allowing remote operations via a smartphone. If the temperature rises above 35 degrees Celsius, the heater automatically turns off to prevent overheating. The current temperature is continuously monitored and displayed in the Blink app. Third, water tank management. The water tank's inlet and outlet valves are controlled through the Blink app. Automatic inlet control. If the water level drops below 2000 liters, the inlet valve opens automatically to refill that tank. Automatic outlet control. If the water level reaches 3000 liters, the outlet valve closes automatically to stop the flow of water. Fourth one, integration and monitoring. The entire system is integrated for seamless operation, providing automation and remote control via the Blink app. Real-time monitoring of temperature and water levels is available through the Blink app, ensuring efficient and safe operation for all systems. Tools used in home automation software. Pixim Lab, Arduino IDE, Blink IoT, hardware, LDR sensor, LED, CLED, temperature sensor, LM35, temperature systems, serial remote tank, ETHW 5500, Arduino UNO. Pixim Lab. Pixim Lab is a real-time emulator of development boards with MP-LabX, AVR GPD, debugger integration. Pixim Lab supports microcontrollers from Pixim, SimAV, UCSim, QEMU, STM32, QEMU, ESP32, and GPSim. Pixim Lab has integrated with MP-LabX Arduino IDE for programming the microcontroller boards. As the purpose of Pixim Lab is to emulate real hardware, it does not have any source code editing support. For code editing and debugging, the same tool used for a real board should be used with Pixim Lab, such as MP-LabX, Arduino IDE, or VS Code with Platform I/O. Pixim Lab supports several devices, spare parts that can be connected to the board for simulation, such as example LEDs and push buttons for simple output and inputs, and some complex ones like Ethernet shield, W5500 for internet connection, and other color graphics display with touchscreen. Arduino IDE. The Arduino Integrated Development Environment, or Arduino Software IDE, contains a text editor for writing code, a message area, a text console, a toolbar with buttons for programming, common functions, and a series of menus. It connects to the Arduino hardware to upload programs and communicate with them. Blink IoT. Blink is a cloud-based Internet of Things platform that helps businesses and developers build and manage connected hardware. It offers a suite of low-code software products that allows users to connect devices, people, and data, and create applications for iOS, Android, and the web. LDR. LDR stands for Light Dependent Resistor, a type of semiconductor component that changes its resistance in response to light intensity. LDRs are also known as photoresistors, photocells, or photoconductors. They contain cadmium sulfide track on the upside. LED. A light emitting diode is a semiconductor device that emits light when current flows through it. Electrons in the semiconductor recombine with electron holes, releasing energy in the form of photons. The color of light is determined by the energy required by the electrons to cross the band gap for the semiconductor. LED contain epoxy lens, LED chip, pond wire, reflector cavity, and two terminals, anode and cathode. CLCD. I2C LCD is a device that uses the I2C protocol to display text and characters on the liquid crystal display LCD. I2C LCDs are used in applications that require a visual or texture display, such as showing information from Arduino projects, like sensor readings, messages, and menus. They can also be used when a character display is needed, but 7 consecutive GPIOs on a single GPIO port are not possible. LM35. LM35 is a temperature measuring device having an analog output voltage proportional to the temperature. It provides output voltage in centigrade Celsius. It does not require any external calibration circuitry. The sensitivity of LM35 is 10 MV per degree Celsius. As temperature increases, output voltage also increases. Temperature system. Pixim Lab has a temperature system that you can use to test board features. The temperature control system consists of a heating resistor, an LM35 temperature sensor, a cool loop, and an infrared tachometer. Serial remote tank. The serial remote tank is a tank simulator controlled by a serial communication protocol. The tank has several sensors and actuators that can be read and controlled using the communication protocol. ETH5500. The W5500 is a 3-in-1 Ethernet controller chip that provides a hardwired TCP/IP embedded Internet Ethernet controller. It's a chip that can be used in a variety of embedded applications, including home network devices, security systems, medical monitoring equipment, and embedded servers. Arduino Uno is a low-cost, flexible, and easy-to-use programmable open-source microcontroller board that can be integrated into a variety of electronic projects. This board can be interfaced with other Arduino boards, Arduino shields, Raspberry Pi boards, and can control relays, LEDs, servos, and motors as an output. And and here is the output image. This output image we got from the final project of the IoT, and we can see the temperature. It's 26.86. In the output image, you can see all the things we have used for the project, like the Pixim lab here, and here is the tank and all the settings. And this is the Arduino Uno application, and we have written all these codes for the functioning of the IoT devices. And you can see a lot of codes we have written for the project, as you can see here. And here we have written the code for temperature and how to handle the tank and everything. I have written the inlet temperature, outlet temperature of the tank and the heater, cooler, everything. Here is the Pixim lab. From here we can see the temperature, it's 27.34, and the flow. And this is the ATMEGA328P. And here we can see the properties of all the spare parts that we have used for the project. As you can see individually for all the spare parts, the properties. And we have used the COM6 serial port for this. And this is the LDR sensor we have used. This sensor is used to turn the lights automatically when the sunlight goes away. It is used for garden lights. As you can see, when I increase this, the light gets on. And this is the blink app we have created. This is the heater off button, cooler off, inlet valve off, outlet valve off. You can see the temperature also here. When we click on the heater, see the temperature is 27.34 and the volume of the tank is 2020. When I turn on the heater on, the temperature keeps on increasing, as you can see here. And I have on the heater, off the heater, and again when I turn on the heater, the temperature again changes. As you can see here, the temperature keeps on varying, and I turn on the cooler. I can, as you can see, the fan is rotating, cooler fan, and the temperature is decreasing now. And now again turn on the heater. As you can see, the temperature is rising. This way we can do this one. This way we can implement this IoT project. As you can see, the temperature is changing now. And this is the tank. The down one is the outlet one. And the top red color, as you can see, is the inlet port. When I turn on the inlet valve on, the water fills in the tank. As you can see, the volume is 3000 liters and the temperature is 29.30. It's showing heater is off. Inlet valve is now off and full. As you can see here. And now I turn on the outlet valve. The water is decreasing. As you can see, the volume is decreasing up to 1960 liters. The tank automatically gets full because we have designed the code that way for the tank. As you can see, the volume is 3000 liters. The outlet. Now again I turn on the outlet valve on. The water is decreasing up to 1960. It automatically rises after that. Now I turn on the inlet valve on. The water is 2730. And now when I turn it off, it reaches 2880. This way we have integrated this project. As you can see, this has been made. And I would like to thank EMERTXE for providing this Internet of Things internship for free. And I would like to thank Jay Lakshmi and Daniel ma'am for providing this internship and helping us.